What's up, you guys? Welcome to trèSci Weekly, episode 33. I'm one of your hosts, Jonathan Ullman, alongside my symbiotic partner, Tom Kea.
Oh boy.
How are you?
Good, man. How's it going?
Not bad, not bad.
And who's the guy on the bottom of the screen?
Joining us for the first time via Skype, resident geologist and widowmain, James Farrell.
What's up?
Hey guys, good to be here.
Thanks for joining us. So Tom, we decided to get James on the show because this week we're going to be talking a bit about the earthquakes that have been going on in Mexico.
Yeah, there was the 8.1 and then the more recent 7.1 earthquakes.
Yep. And so James, who has been studying geology, and specifically, we were in a geophysics class all together in college.
Oh yeah, we were all in the same class.
Yeah.
I forgot about that.
James can definitely shed some insight into what's going on as far as the plates and the motion of the plates and the earthquakes that have kind of sprung from that. So we'll be looking forward to hearing from you on that, as well as you just joining us for the rest of the show, because, hey, you're a scientist, so you're probably more qualified to talk about all this stuff than we are.
Somewhat.
So if you guys are just joining us for the first time, thank you so much for watching. This is trèSci Weekly. This is our weekly video podcast where we talk about trending science news topics, chatting with you in the live chat. If you're watching live with us, we invite you to watch live on Monday nights at 8:30. If you can't, no big deal. You can always catch the replay on YouTube, on our YouTube channel.
Yes, sir.
We would ask that if you like what you see here, please subscribe to the channel. That always helps grow the audience. You can also like us on Facebook.com/trèSci Weekly. You can follow us on Twitter.com/trèSci Weekly. Trying to kind of stay in the community, stay in the know of some of the things that we're going to be talking about on the show. And if you felt so inclined, you can always donate to our Patreon. We have a Patreon page up, so that is patreon.com/trèSci Weekly as well.
All right.
Without further ado, let's get on right into the news. Not too many stories to go through, but some.
We'll go into them in some depth this week.
Exactly. So I want to start, actually not with the earthquakes. I want to start with what's been going on in Puerto Rico in terms of Hurricane Maria.
Sounds good.
So on Wednesday, September 20th, Hurricane Maria made landfall in Puerto Rico as a Category 4 storm, the third major hurricane to make landfall in the United States within a 4-week span. The island has been devastated, with many areas ravaged by 150-mile-per-hour winds, over a foot of rainfall triggering flash floods, and the entire island has been without power, more or less, since Wednesday night.
Yeah, so Maria was a pretty impressive storm, and still was when it made landfall in Puerto Rico. It got hit by when it was still a Category 5 storm,
right?
I believe, or transferring into a Category 4. But it got hit right on by Maria, which was pretty devastating.
Yeah. So I don't know. Have you guys seen some of the images from what's been going on down there?
Yeah, I've seen a few of the pictures. I've seen some flash flooding pictures, and just, like all the trees, they look like palmish type trees, like tropical trees. In one picture before, they're all there, and then after, there's no leaves.
Yeah.
The wind just ripped everything away.
Yeah.
Yeah, I think the CNN headline today put it well, said it looked like a bomb was dropped on Puerto Rico, and that's what some of the pictures definitely look like.
Yeah, I mean, the amount of energy that that hurricane generated and basically left a wake of in its path is pretty much equivalent to something like a bomb being detonated there. It's almost
the overall energy of the storm.
Yeah.
And it was across the whole territory.
Right.
Yeah, all of Puerto Rico got hit.
Right. So I want to, before we move on with anything else that I have written here, I want to actually bring up a link to a donation fund that people can donate to, because the people down there are, not going to be with any electricity for what seems like many weeks, if not months. And that's a scary situation when, you're living in essentially flooded territory.
With high temperatures.
Yeah, high temperatures, food and gas is scarce. So I would ask everybody, Kyle can bring up the images here. I would ask everybody to, if you can, please consider donating to HispanicFederation.org/donate. I personally made a $50 donation this afternoon, which, I don't want to pat myself on the back, but I wish I could have donated more. Just a lot of severe humanitarian crisis going on down there, and
because they're still a part of the United States, but it seems like the response for recovery is nowhere near what it should be, right?
So far, I mean,
at this point.
Yeah, we haven't really seen anything really generated federally. There have obviously been a lot of relief efforts, more localized relief efforts being organized. But yeah, it's a real mess down there. So if you guys can and would donate, that would be much appreciated. There's quite a bit of devastation going on down there. Moving ahead, the first image that I want to bring up that sort of goes along with the storm is a NASA image by NASA Goddard that shows the rainfall accumulation that Maria sort of dumped as it made its way to the northwest. And so you'll see on the scaling down here in the bottom left corner, the purple indicates
it's like the heaviest of rain.
Yeah,
and then the red being heavier next. I mean, slightly less heavy.
Right, and so some areas of Puerto Rico in the northwest got 20 inches of rain. That's almost 2 feet of rain. That's a lot of water. And the problem with this, particularly in Puerto Rico, is it's got somewhat of a mountainous terrain, and so as this water makes its way, downhill.
Yeah, as it all lands, it's got to all go somewhere.
Right, and it sort of accumulates into channels that are rushing water more swiftly than others.
Yeah,
and that can be a force to reckon with. So this was one of the more insightful sort of graphics that I could find about this particular hurricane.
Just to add on to that too, it's nice that we have the satellite data because the Doppler radar in Puerto Rico is actually destroyed. So we were sort of relying on the satellite imagery for the most part during this storm.
Mm-hmm. That's true, yeah. So I actually don't want to speak too much about the hurricane itself.
Because we talked about a few other hurricanes.
Yeah. Unfortunately, we've had to talk about major hurricanes quite a bit on trèSci the past few weeks. So I don't want to beat anybody over the head with it. By this point, we kind of understand what it is, what a hurricane means, and the winds and the damage can be from them. Instead, I want to focus on a particular area of Puerto Rico, and that would be both the town and the Observatory of Arecibo, which is a radio telescope.
The town is also the town of Arecibo?
Yeah, okay. That's right. So, as some of you guys may already know from our previous coverage, Arecibo Observatory is one of the world's largest and most iconic radio telescopes that's located in the northwest part of Puerto Rico, where we can see some of this most heavy rain.
So do you happen to know why they decided to build Arecibo in Puerto Rico? Is it like a good location for the radio telescope, or?
That's a great question. I'm not entirely sure why they built it
in that location
there to begin with.
But anyway,
yeah, sorry, losing my train of thought. The reason I wanted to focus on this is, well, it's kind of a double whammy science topic for us to discuss. But also our good friend Tyler Cohen,
who was on trèSci.
Yep, who was on trèSci a few months ago now. He had actually done a summer study at Arecibo Observatory, and this is of particular what's going on. A lot of his mentors still live and work down in this area. And so he kind of reached out to me and asked us to cover this because some of the mainstream media outlets are not. And so I wanted to do that on his behalf and just on behalf of all those people that are dealing with this down there.
Sounds good.
So I'll ask Kyle to bring up just quickly the next image. It's just basically a basic image of Arecibo, courtesy of NAIC and Arecibo Observatory, just so everybody knows what it is we're talking about. This is not after the storm. This is just kind of a normal situation. So you can see that the radio dish here is monstrous. It's one of the largest radio telescopes in the world, only recently being surpassed by the Chinese FAST radio telescope. And it's very iconic. It's one of Puerto Rico's kind of hallmarks and a big tourist attraction as well.
It's pretty impressive looking.
It is. I've never been to it personally, although I did actually get to meet once with the director of outreach from Arecibo Observatory when I was at a meeting in BNL. So that was kind of interesting.
You can also play this on a map in GoldenEye, right?
That's true. That's true. The classic.
Very true. Iconic.
Yes, we've all been there. So while the relay of information has been difficult due to the nature of the situation, National Geographic's Nadia Drake provides an article with some valuable insight to the extent of the damage. Quote, because of the storm, a 96-foot line feed antenna, which helps focus, receive, and transmit radio waves, broke in half and fell about 500 feet into the huge dish below, puncturing it in several places, says Pennsylvania State University's Jim Breakall, who talked with Angel Vasquez, an Arecibo telescope operator who managed to get to the site and communicate via shortwave radio in the early evening of September 21st. A fixture of the observatory since 1966, that line feed weighs about 10,000 pounds and is easily visible in images of the telescope as the pointy thing hanging off the platform. It was once used to detect mountains on the surface of Venus, and it is still crucial for studies of the part of the Earth's atmosphere called the ionosphere, says former observatory director Frank Drake, who is also my dad, end quote. So, reliable information.
That's pretty good.
The former director is kind of helping this along. Nadia Drake also on Twitter provided a before and after photo of Arecibo's line feed here, so I'll ask Kyle to bring those up for us as well. We'll start with the before picture. And this is basically suspended on cables above the dish that we saw in the last image. And you'll notice kind of to the right of this more circular piece here, this is the line feed that they're talking about.
When I said that thing weighed 10,000 pounds, the thing must be massive.
Yeah.
That's crazy.
I mean, it's also pure steel, so.
Yeah, steel's heavy.
Yeah.
Yep.
And then if we swap to the after image, so this is after Hurricane Maria came through. You guys can see there's no longer the line feed there anymore. This is kind of the opposite direction. Yeah.
It's still see it's out there.
Right. So yeah, the line feed would be on the left side now of the more circular piece here, and it is not there. It's snapped off.
So the last time we covered Arecibo, we were kind of talking about the fact that they kind of wanted to defund it, right?
Well, yeah,
we're gonna get to that.
We'll get to that in just a second. I wanna finish up with some of the extent of the damage going on there. So in addition to the 430 megahertz line feed, a smaller 12-meter, very large baseline interferometer dish was damaged. This is according to our friend and guest of trèSci Weekly, Tyler Cohen, who I mentioned before. His mentors actually took shelter in the town of Arecibo, and the town actually seems to have undergone much more catastrophic conditions than the observatory itself. We know this according to a tweet by Alessandra Springman, who has also been in contact with those who took shelter at Arecibo. And she wrote, or she got information from somebody there that said, quote, there were 39 inches of rain for Maria, About 20 panels of the telescope dish were damaged when the line feed fell. Wind miles per hour, 150 miles per hour in the city. Hospital on Route 129 has collapsed. There is much damage along the Arecibo seafront road. The hospital on this road is sliding into the sea. Water damage in the observatory control room and transmitter operations room. Multiple panels of the catwalk up to the telescope platform blew away during the storm. Crews are going to try to go up on Monday. That would be today. No news yet on the instruments inside the Gregorian dome, end quote. So, hospitals that are being demolished, sliding into the sea. Arecibo is located in more of a remote location of the island of Puerto Rico. So there's really only one road in and out. And that road is now passable, I believe, but for a long time was not. And so the people in the village and at the observatory were kind of really stranded without supplies other than what was on site at Arecibo. Yeah. So really frightening situation going on down there. What do you guys make of that?
I got to give kudos to Angel. His town is facing complete devastation. He goes to work and checks on his instruments. So good on him.
Yeah.
I mean, Puerto Rico is not receiving aid as it is, and correct me if I'm wrong, but if this is U.S. funded in the current administration, science money is already thin, so I think it's going to be a long uphill battle to get this great piece of scientific instrumentation fixed, which really sucks.
Yeah.
Yeah, the last time we were talking about Arecibo, they were trying to defund it in the first place.
Yep.
And actually demolish it, but it was too pricey of an endeavor to undergo to demolish the whole thing. So they were kind of still just using it as much as possible.
Yeah. Yeah, so I'll finish off with that point because, one of the big questions is, of course, what happens next?
Yeah,
right?
What do we do now?
Well, according to the National Science Foundation, about 2/3 of Arecibo's operating costs. Quote, while we know that there is some damage to Arecibo Observatory, we do not yet know the full extent of the damage. When the situation becomes more clear, NSF will be able to determine the appropriate response to any damage to Arecibo and the other NSF-funded research infrastructure in Puerto Rico. We do not yet have a timescale for when such an assessment would occur. After NSF is able to determine the full extent of damage to Arecibo Observatory, we will evaluate whether any adjustments need to be made to our ongoing environmental review process regarding future operations of Arecibo Observatory, end quote.
Okay.
So it all kind of sounds bureaucratic and what you might expect as an official statement until that very last point there, I think. I think, we can read between the lines here a little bit where they say, we will evaluate whether any adjustments need to be made to our ongoing environmental review process regarding future operations of Arecibo Observatory. And this is what we've brought up in the past, is that, they're looking at, what is the cost effectiveness of maybe shutting this whole operation down, removing Arecibo, and letting kind of the environment just be as it is. And we were stunned when that was on the table because that was going to be a very costly endeavor, more costly than just keeping the telescope running for the next few years. But now, Tom and James, with damage that is likely to cost a lot to just replace the already pre-existing infrastructure.
Yeah, it seems like a convenient thing to happen for people who are, trying to cut the funding and get rid of it, which is unfortunate.
Mm-hmm. So I should note that I don't exactly remember what branch of NASA, but some branch of NASA is the 1/3 funding for Arecibo. So what do you guys think is the likelihood that if NSF is trying really hard now to pull out of Arecibo, what do you think the likelihood is that NASA or another agency is able to maybe come through with the funding deficit there?
Yeah, I don't know. That's tough.
It's going to come down to the merit of what other projects are going on at Arecibo, what's proposed to be, done at Arecibo. I'm not an astronomer, so I don't know what goes on there. But if there's some, cutting edge astronomy going on there, worth saving it, multi-million-dollar grants, things like that, then they'll put it in. But who knows how long it's going to be before they can even get up there with cars and trucks and workers,
Yeah.
But it's all gonna come down to merit of the projects. It's I looked at the list of achievements for this thing. It's over 50 years of just amazing discoveries, but that doesn't mean anything for its future, unfortunately.
Right.
So.
Yeah, that's a good point. It's done a lot of iconic stuff in the past, but at its state right now,
yeah, I mean, it's
up
not
in the air.
It's not doing much right now as we speak, unfortunately. So, yeah, I guess we'll continue to monitor the situation down there, and we'll continue to update on what it seems like NSF and any partners with Arecibo are willing to do and willing to fix.
Yeah, it's a pretty messy situation down there, and a lot of things need to be dealt with, so I'm not sure we'll get a timely update with what's going on with this,
Yeah.
There's a lot of stuff that needs to be taken care of down there.
Yeah.
Right,
So
low priority
we'll see
to the
eventually,
people in Puerto Rico, too.
Yeah, I'm sure.
Yeah, they're like, we need food and water, and that's about it.
Yeah.
That kind of stuff.
So once again, just if you guys have it in your heart to consider donating, please consider it. Puerto Rico is a part of the United States, so it's a shame that there hasn't been really an official response of relief efforts yet, but we can do it on our own. I actually emailed Tyler back and told him that the light at the end of the tunnel here is that we do live in the day and age where the relay of information was made possible through free platforms like Facebook and Twitter, and we can organize a relief effort just by spreading the word, like we're doing right now on YouTube and Skype.
Yeah, there was a lot of good relief efforts for like Harvey, where J.J. Watt from the Houston Texans helped donate a lot of money, so hopefully some other celebrities and people, and the word still gets out for Puerto Rico.
Absolutely. All right, moving on. Our second story, unfortunately, the natural disasters don't seem to stop for North America. On Tuesday, September 19th, a magnitude 7.1 earthquake struck central Mexico. Its epicenter located approximately 55 kilometers or 34 miles south of the city of Puebla. According to Mexican authorities, 319 people have been reported killed, and many more have been injured and left homeless.
Yeah, so right after the quake, me and Chrissy were watching the news, and it was crazy to watch them trying to pull people out of the rubble. And there was a guy next to all the rubble, and he would put the sign up for silence because they needed like the whole crowd to shut up so they could listen for people in rubble. It's a pretty crazy situation that they had down there with a lot of buildings collapsing.
Absolutely. The quake occurred on the 32nd anniversary of the 1985 Mexico City earthquake, which killed about 10,000 people.
So it happened to the day?
Yeah.
That's insane.
And ironically, a national earthquake drill took place at 11 a.m. local time, 2 hours before this earthquake struck.
That's so funny. That's crazy.
Yeah. So, what are the odds of that?
Yeah.
We have a couple images, not of the wreckage post-earthquake down there, but more science graphics.
To get an idea of what was going on with this earthquake?
Yeah, I figured most people had seen some of the footage of this already on the news, and I didn't want to show anything too graphic on our channel here. But I did want to bring up the USGS shake map.
The shake map.
So James, actually, I would be honored for you to kind of describe what we're seeing here on this map.
Sure. So just so we're on the same page, you're looking at the shake map with the Roman numerals on it?
Correct. Yep.
Okay. Yep. Yeah. So what we're looking at here is what's called the Mercalli index of shaking. It's a quantitative, or rather a qualitative measure of basically the damage that's caused by an earthquake. It goes from 1 all the way to what I think 10 or 10 plus.
It looks like 10 plus.
Yeah, and these maps are generated by actually going out in the field and looking at the damage and giving it an assessment. So you see on the outside these outer blue lines, really far from the earthquake. 3s and 4s, they have indicators like dishes falling off shelves and chimneys falling off exterior buildings and things like that, and it goes all the way up to 10, which is just complete destruction of standing structures. So right at the epicenter, we've got, I think it's was it 9? No, 5, 6, 7.
7. Yeah.
7. Yeah. So we have a Mercalli of 7, which is, it's pretty bad. You have destruction of some poorly engineered standing structures, things like that. And then Mexico City itself is in the outer green one, which is probably closer to a 5 or 6, which is still intense shaking. And I saw the videos. There was buildings going down that were probably on the lower end, engineering wise. And without the warning system in place, people probably didn't get out of them.
Mm-hmm.
Yeah, I was reading that most of the buildings to fall were sort of like pre-1985-ish type buildings, where obviously they had less codes and standards and things.
Right.
So if they were before a certain area, most of those buildings collapsed within the city area.
Right.
But, that's bound to happen.
A quick question for you, James. Does this shake map, do the Roman numerals here tend to coincide with when we say it's a magnitude 7.1? Does that always seem to be a one-to-one, or
it's not always. So the higher the magnitude, the higher the amount of energy released from an earthquake. Mm-hmm. So that's a quantitative measure of the energy coming from that earthquake. There's a lot of different factors to how that energy actually propagates and reaches the surface, and the amount of shaking that occurs at the surface. So you can have relatively small earthquakes have very large amounts of damage depending on the depth, the geometry, things like that. And conversely, you can have very big earthquakes. For example, the previous 8.1, very big earthquake, do less damage.
Right.
An example would be Haiti in 2010, I think it was, was the same magnitude as the Mexico earthquake, as a 7.1. But there were hundreds of thousands of deaths. And the Mercalli index for that would have been much higher because of the massive extent of damage. So it depends on a lot of things.
Gotcha.
So the magnitude of the earthquake alone is not enough to tell you how much shaking and damage there's going to be.
Right.
It matters. There's more factors to it. Yeah.
Got it. So the other image that I have here is an image also provided by USGS. This one is, I believe, looking more or less at a model of what we might see underneath the surface if we're talking about the plate tectonics of this particular
what's actually
incident.
happening structurally, right?
Right. So in the sort of right-hand corner of this, we can see Mexico as on the map there, and it looks like we are seeing kind of where that beach ball image is. That would be, I believe, the epicenter of the earthquake's location, and sort of how the plate moved in order to cause this particular quake. And I'm sure James can elaborate a little bit more on what we're seeing here. So again, I'd be honored for you to explain it a little bit more.
Yeah. Yep. So exactly, it's plate tectonics. Geology 101. If you have an oceanic plate colliding into a continental plate, I'm going to use my mentor Bill Holt's hand motions here. The oceanic plate is more dense and therefore goes underneath the continental plate, and that's what you're seeing. That's what they outlined as the slab surface. The downgoing plate they sometimes call slab. And this is the cross section you would see anywhere around the Pacific Ring of Fire, pretty much. So although these earthquakes in Mexico were devastating, they were by no means a surprise. These are something that happens. Magnitude 7 happens about a dozen times a year, but the only time general public hears about it is when it happens under a major population center.
Right. Yeah, exactly.
So they're showing in this diagram where approximately the location of that downgoing plate is, what its depth is under the North American continent. And you can see the black dots are historic earthquakes, so earthquakes in the recording era past 50, 100 years. And that red dot is the I believe the 919 earthquake. I think that's the 7.1. the Mexico City earthquake, not the earlier one.
Right.
I think going deeper into the science, what was surprising about these earthquakes is the biggest fear along the Ring of Fire, along these big subduction zones on Western North America and Eastern Asia, is what's called a megathrust earthquake. And that's when you have an earthquake that's sliding right in between that big continental mass and the undergoing plate. So that's what happened in Japan in 2011, was it?
Yeah, that was pretty devastating for Japan. Yeah.
So that was a 9 or a 9.1, and those are, which on the magnitude scale, it's logarithmic. So the difference between a 7 and a 9 in terms of energy is 1,000 times. So it's 1,000 times more energy released than this Mexico earthquake. And those are known to happen on subduction zones. What hasn't really been, I mean, I'm sure it's been seen before, but it's pretty uncommon, is that these faults that ruptured in the Mexico earthquake were actually inside of the subducting slab, which usually we think is a nice rigid body that doesn't break internally. And if it does, it's really not, the earthquakes aren't very big. They're what's called normal faults, which are kind of gravity driven, and the stresses associated with normal faults don't cause that big of an earthquake. But I think this 8.1 and then the following 7.1 really kind of sparked the interest of some scientists that didn't know we could get these kind of earthquakes at that size.
Right.
Yeah, so for this one, just to kind of re-summarize, make sure we're all on the same point. So along the Ring of Fire, where we have these subduction zones, and they're going down beneath it, the most dangerous ones are actually between the continental and the oceanic crust, where the movement is occurring. Those are where you can get some of the biggest, most powerful earthquakes, I think.
Yep.
And then this one was actually within the plate itself that's subducting beneath it.
Right.
Exactly.
Right.
But still getting a magnitude 8 and 7 from that type of earthquake, that's kind of crazy, like we were saying.
Yes.
That's pretty high still.
Yeah. So I guess the key point here is we have to keep in mind that the plate itself is a three-dimensional object, right? It has some girth to it, I guess. And the earthquake seems to have existed within the one plate itself, but enough energy was released from whatever motion occurred there that it still caused major shaking above ground.
Yeah.
Yep.
So I'd like to, if you guys don't mind, I'd like to read the tectonic summary provided by USGS, and both of you can feel free to kind of pause or stop me along the way, because there is some vocabulary in here, that maybe our audience or even myself hasn't been familiarized with. So yeah, feel free to stop me at any point and just kind of, in layman's terms, explain what it is they're putting out there. So the tectonic summary provided by USGS states the following, quote, "The September 19th, 2017 magnitude 7.1 earthquake in central Mexico occurred as the result of normal faulting at a depth of approximately 50 kilometers. Focal mechanism solutions indicate that the earthquake occurred on a moderately dipping fault, striking either to the southeast or to the northwest."
So I feel like we should stop there and see if we could say anything about it. So like we said before, normal fault, which James mentioned was more from like gravity as opposed to the
normal fault basically means that your highest stress value, your force that's causing the faulting, is vertical, which in the earth is usually gravity.
Mm-hmm.
Gotcha. Instead of the actual pushing of the plate downwards, you're pushing with gravity, so that overriding crust, that Mexico sitting on top of that plate, is pushing down, and it's going to create that vertical force.
Right.
Okay. And then at a depth of about 50 kilometers, how deep is that, James? Is that like typical 50 kilometers? Is that kind of deep?
So it's Yeah, considering where the slab is in this situation. So in Mexico, if you remember, that cross section showed the slab going under. I don't know if you're still showing it or not, but the slab is under about where Mexico City is. You have to go 50 kilometers down to hit that slab.
Right.
So that's where the earthquakes occur, and then within the first 2 kilometers or so of that slab, which is where we're getting these normal faults.
Right. It looks like on that graphic that the that red dot was sort of close to the slab surface, but shallow to the slab surface, but still pretty far beneath the Earth's surface, if that makes sense.
Yep. Yeah. So another thing to consider is that when these ocean slabs dive under, they're not going under as a perfectly rigid body. They have pre-existing faults that formed when the crust formed at the mid-ocean ridges. So you look at an ocean crust and it's just lined with all of these cracks and faults, and it's a broken up body. So when you apply stress to something that already has cracks and faults in it, they're going to easily jostle around. And in the ocean slabs, those faults, those pre-existing faults, are in the upper few kilometers of the slab. So that's why this normal fault cracked at the top of the slab. It was technically within the slab, but to our resolution,
Right.
it kind of looks like it's at the surface, but it's a different mechanism.
Right. Moving along with the quote here, the event is near but not directly on the plate boundary between the Cocos and the North American plates in the region. At the location of this event, the Cocos plate converges with North America at a rate of approximately 76 millimeters per year in a northeast direction. The Cocos plate begins its subduction beneath Central America at the Middle America Trench, about 300 kilometers to the southwest of this earthquake. The location, depth, and normal faulting mechanism of this earthquake indicate that it is likely an intraplate event within the subducting Cocos slab, rather than on the shallower megathrust plate boundary interface. And I think that's speaking to what James was explaining to us earlier, that it exists within the Cocos plate itself, not
on that
at the boundary. Right. While commonly plotted as points on maps, earthquakes of this size are more appropriately described as slip over a larger fault area. Normal faulting events of the size of the September 19th, 2017 earthquake are typically about 50 by 20 kilometers length by width. Over the preceding century, the region within 250 kilometers of the hypocenter of the September 19th, 2017 earthquake has experienced 19 other magnitude 6.5 plus earthquakes.
Yeah, so kind of like we mentioned before, you don't hear about all the earthquakes that occur. There's a lot of earthquakes every day.
Right. The ones that make the news are the ones that demolish buildings and people, for that matter. Most occurred near the subduction zone interface at the Pacific coast to the south of the September 19th event. The largest was a magnitude 7.6 earthquake in July 1957 in the Guerrero region, which caused between 50 to 160 fatalities and many more injuries. In June 1999, a magnitude 7.0 at 70 kilometers depth just to the southeast of the September 19th, 2017 earthquake caused 14 fatalities, around 200 injuries, and considerable damage in the city of Puebla.
So I think that goes to what James was saying, is that these were not a surprise. This is where earthquakes occur.
Yep.
This is where you would look for.
I'm going to skip down, instead of going through all the history of this particular area, I'm going to skip down to a point that I think was pretty interesting here. Today's earthquake also occurs 12 days after a magnitude 8.1 earthquake offshore of Chiapas in southern Mexico, and that's what we've been referencing to as well, this magnitude 8.1 earthquake that struck previously.
Yeah, that one happened right during Irma, and then this one happened during Maria.
Right.
And Irma and Maria are anagams for each other, and they had each an earthquake. I mean, conspiracy theories, so forth.
Yeah. The epicenter of the magnitude 8.1 event is located about 650 kilometers to the southeast of today's quake. That earthquake also occurred as the result of normal faulting within the subducting Cocos plate at a depth of 50 to 70 kilometers. As of September 22nd, USGS has not detected any aftershocks for this earthquake. However, Universidad Nacional Autónoma de Mexico, or UNAM for short, has reported several aftershocks of magnitude 4 and below using data from their dense regional seismic network. This low rate of aftershocks is not typical for earthquakes of this size, but has been observed for other intraplate earthquakes, such as the 2001 Nisqually earthquake and the 1999 Puebla, Mexico earthquake. End quote.
So both of the earthquakes occurred, they're saying, both intraplate within the plate itself.
Right. So a lot of similarities between these two earthquakes. And I think one of the natural questions that a lot of people would have then, James, is does one lead to the other? Are these two events related in terms of, the physics that happened here?
Yeah. Yep. And if you can prove that, definitely you'll get published in Science and Nature immediately. It's a subject called earthquake triggering. It is, as you can imagine, these things are happening 50, 100 kilometers down. It's very difficult to prove causation. It's a nice coincidence. It's a really big earthquake, another really big earthquake with the same mechanism really close by. And there's physical properties we know. If an earthquake occurs, it can relieve stress in some places and increase stress in other places. Mm-hmm. So if you have an earthquake that fails and it increases stress in a place that has a fault ready to go, then it would cause an earthquake. But actually proving that connection is very difficult. You can do a lot of computer modeling, and there's already abstracts and papers out on this subject on Mexico showing that, I believe the one I saw today, the 8.1, the geometry was such that it increased stress in such a way that it could have caused the fault to slip in Mexico City, the 7.1.
Gotcha. Okay.
So
but it's so hard to say definite causation.
Yeah, very, very difficult to say, because you have to make a connection between two things that are, 600 kilometers away from each other through the earth that you can't see underground.
Yeah.
So,
right.
So just looking at the chat, James Carey in the chat said he'd like to know how do they determine the depth of the earthquake?
It's a good question. Has to do with a lot of basically three-dimensional triangulation. You can only measure earthquakes from the surface, right? You measure the ups and downs and the lefts and rights and the jostling of the land. And what we teach kids in Geology 101, if you have 3 separate seismometers,
then you can determine the location.
You can triangulate, yep, because when an earthquake ruptures, it sends out a bunch of different forms of energy in mechanical waves. We have P waves, S waves, surface waves. We know the speed of those waves through solid rock. We know that P waves are the fastest, they travel at a certain speed. We know that S waves are the second fastest, they travel at a certain speed. So if we know the difference in speeds and we know the difference in distances from one seismometer to the next, we know how far away that earthquake has to be from a certain seismometer. So we can say, okay, there's a seismometer in Mexico City. We know that this offshore earthquake was 600 kilometers away. So we can draw a sphere around that seismometer, and that's 1 point. And then we get another seismometer from northern Mexico, say, okay, it was 1,000 kilometers here, draw another sphere, and then do it again. So in theory, it takes 3 seismometers, and you can triangulate the exact point in the earth for an earthquake. And then the more seismometers you have, the better accuracy you have, and so on.
Gotcha. So when we're talking about the devastation of the shaking, are we talking about P waves or S waves that are causing the shaking?
So the shaking is actually the surface waves, which are the slowest. The P and S are what we call body waves. By definition, they travel through the body of the earth. As soon as we start feeling things at the surface, those are surface waves. Gotcha. So that actually is how earthquake early warning systems work. And there is one in place in Mexico, and it worked in the 8.1. You can detect P waves. We can't feel them if we're walking around if they're too small. You can detect P waves. If you detect them and they're a certain size, you can send out an alert and be like, hey, in 90 seconds, there's going to be really intense shaking. Get under a desk, get outside. And they did that for the 8.1, and it worked really well.
That's pretty cool, yeah.
I read that there was also an alert that went out for this one, but I believe there was only about 20 seconds or so notice.
Right, and that's because it was a lot closer to Mexico City. The one offshore, they had a good amount of time in between the arrival of the P waves and the surface waves, so I think it was about 90 seconds was the alert they were able to give. This second earthquake occurred really close. You saw the map, really close to Mexico City. So that
Right.
difference in arrival time between the first waves and the damaging waves is just a few seconds, which can make a difference. And they were able to, I didn't read about the earthquake for the second one, but I'm sure it probably saved some lives.
Yeah. Well, thank you, of course, for your insight and for your knowledge in this matter, James. Again, we wish our best to our Mexican neighbors down south there in dealing with this. But like you said, James, I mean, this comes as a not really a surprise when you live on a fault system such as Mexico City is located nearby one. And I think it should go without saying that, if you're living in the United States on a fault system, that these are things that you need to be prepared for and think about, and not let your guard down.
Yep.
So
the scientists say Seattle's next, so.
Yeah, Seattle. Oh boy.
Yeah, yikes.
Seattle, Vancouver.
Well, we'll see. Hopefully not this year, because we've had a lot of heartbreak already this year.
There's not enough money to go around.
Yeah.
Everybody.
Couple more quick stories just to wrap up here a little bit, guys. Number 3, a new species of hermit crab, Diogenes heteropsemicola, ditches the shell in favor of a living solitary coral, according to a study by Momoko Igawa and Makoto Kato of the University of Kyoto in Japan. I have an image to share with you guys of the hermit crabs here.
Okay. Oh yeah, I actually saw this image many times.
Probably turned
Twitter,
throughout Twitter. So,
before I had context, I didn't relate that image to this story.
Yeah.
Gotcha.
So this is the hermit crab here in panel A on the left, residing within the coral, and then if the hermit crab was extracted from the coral, it would look like it does in panel B on the right. So you can see a nice, really slender kind of tail-like feature here, and it is, what the researchers found is that it is more symmetrical than other species of hermit crabs that reside within shells that kind of pivot to the right or left.
Gotcha.
Right? There are other interesting things about this research, though, guys.
Okay.
The hermit crab, which was identified in the shallow waters of southern Japan, engages in a symbiotic or mutually beneficial relationship with the walking coral. So, Tom, what is a symbiotic relationship? Because I introduced you as my symbiotic partner.
Well, yeah, that's when one animal sort of sees a way to benefit themselves, and by doing that action, they sort of are a part of the other organism's system, and they mutually help each other out to survive in one way or another. And it depends on each relationship on what they do, but you can have all different kinds of symbiotic relationships.
Right. And these are usually pretty specific as time goes on, long periods of time goes on, because
where
now
the organisms interact with each other.
Right. And evolutionarily, they sort of...
They're codependent on each other.
Right.
They're dependent on each other.
Right. So unlike most other corals, the walking coral does not attach itself to the sea floor. Instead, the coral grows around and with the hermit crab, providing a home for the crustacean that doesn't need to be replaced like the traditional mollusk shell.
Genius.
Yeah, so, right, I mean, hermit crabs go through that period where they outgrow their shell, they have to leave it and find a new shell, and that leaves them pretty vulnerable to...
It's risky business.
Right, to prey. Whereas in this relationship, the coral actually grows along with the size of the hermit crab, so it never has to leave, which that's pretty awesome.
Yeah, it's a convenient relationship with a hermit crab.
In exchange, the crab gives the coral mobility and keeps the coral from becoming buried in sediment, right? Because they don't attach themselves to the seafloor and they don't grow in colonies. They're solitary. So if some water motion, buries it, then that would just be the end of the coral. And so the crab, if that happens, will dig itself out, and they can go about doing their business. One of the more striking aspects of this finding, however, is that walking corals are already known to exist in a symbiotic relationship with a different organism, the sipunculid worm, or a peanut worm. I have an image of that worm to show you guys as well. Kind of gross, but this is what a peanut worm would look like.
Okay.
And so these guys already do what the hermit crab does to the coral. They live inside of it. So, according to the study here, right, this is an interesting case, quote, "This is an interesting case in which an organism phylogenetically distant from the sipuncula takes over the symbiotic role in association with a walking coral," end quote. All right, so you might expect a symbiotic relationship to be replaced if, you know, it was a sea worm that is similar in nature to this peanut worm that we're seeing here. But a hermit crab and a peanut worm
are quite different.
Quite different, right? So we don't really expect that to happen. One of the big questions the researchers hope to answer is which species originally developed a symbiotic relationship with the coral, and which is the secondary alternative. More signs point to the sipunculid being the original, since the worm's body can completely fit inside the coral, as well as the prevalence of sipunculids living within the range of the corals. The slender body of the hermit crab is more than likely an adaptation driven by evolution, though further research into the history of the symbiotic relationships is needed. And the image credit for the first image of the hermit crabs goes to the study, right? And Igawa and M. Kato. And then the second image credit of the sipunculid goes to Chaloklum Diving. So what do you guys make of that?
So what does a coral get out of this?
So the coral gets mobility, right?
Oh.
It's able to move along the ocean floor and probably pick up on little plankton or bacteria or whatever the hell coral eat. And also because it's a solitary creature, that if it were to get buried by sediment, the hermit crab, or the worm in this case, would be able to dig itself back up to the sediment surface.
Cool.
Yeah, so the coral is the one that has both of the relationships.
Correct.
Basically, yeah.
Yep.
I mean, I guess that kind of makes sense because I don't know, it's not like a really dynamic organism, you know, it's kind of simple.
Yeah.
So easily to just become part of something else,
Yeah.
I guess.
So, can I share what came to mind when I was reading this story to you guys?
Yes.
Sure. Okay.
This symbiotic relationship reminds me of Kyle and his RV, where the RV can't exist without Kyle driving it around. It becomes its home. And Kyle, you know, can't travel the country without the RV.
Who's the worm then?
The
That was the previous owner?
Yeah. I don't know. No comment.
Well, I'm definitely not a biology expert, but I think this would be a super interesting creature to study in the context of climate change. There's a huge drive right now to study corals in that context because they're super sensitive to climate change. I'm sure you've heard of like the mass coral bleaching along Australia and whatnot. Mm-hmm. I wonder if that would kind of change this situation. Maybe the hermit crab will start making regular shells again.
Yeah.
I don't know.
Interesting as well that this is just a new species of hermit crab that is first being discovered.
Yeah, we'd never even heard of the crab.
And upon discovering it, it's got this like crazy little attribute going to it. So definitely interesting. And the last story here, guys, is just actually a preview of an upcoming book release titled Our Shrinking Planet by Massimo Livi Bacci. Bacci. I want to read the little description.
So how are we shrinking? What do you mean?
Well, let me read it and then we'll discuss a little bit here. So the description for the book is as follows, quote, "In the space of another generation, the population of the Earth will rise by 2.5 billion. Yet the real problem we face is not so much the increase in numbers as the fact that growth will be highly uneven. Whereas rich countries will see aging populations with little growth, populations in poor countries will double or even triple, having a much higher percentage of young people. Against this backdrop, demographer Massimo Livi Bacci examines the implications of this disproportionate demographic development for domestic social stability, international migration flows, and the balance of power among nations and the natural environment. Covering 10,000 years of human history from the Stone Age to the present, Livi Bacci shows how the space available for every inhabitant of planet Earth has decreased by a factor of 1,000. The notion of limits to the world's capacity, which once seemed a remote matter, is now among the most pressing issues we face, and the need to create effective global mechanisms for sustainable development is now more urgent than ever. An indispensable book for anyone concerned with the moral and political implications of our ever more crowded planet, end quote. So this is something that you and I have touched
We've
upon
mentioned it a few times.
a number of times. I'd be interested to get your perspective on this as well, James. How do you feel about the population, not so much a crisis, but the population problem that we have here?
I mean, it's no joke. It's a massive problem all over the world. I think this perception he's showing is very interesting. And I remember learning about it in some gen ed at Stony Brook, where they show basically the population distribution. It's like, this is what it should look like. This is what it looks like in developing countries, and there's just this bulge of young people.
So weird.
And it never really got to me like what the significance of that was. But you know, the population problem is incredible, and the habitable space argument is very interesting, because I don't know what the statistics are, but like for every human born, there has to be so many acres of farmland for food, right? It's not just a person being born and they need a house and a car, and that's their space. They need a factory to build all of their stuff. They need crops to feed them. All of these external factors that you don't really think about, and how it can greatly affect the planet we live on.
I think about it in terms of the juxtaposition that we face here, especially in this country, where the higher number of people that live within the United States, especially in a concentrated area, the less freedom each individual actually has, right? And kind of the way that I would point this out is that, so kind of menially speaking, like here where we live, Tom, in Suffolk County, there's not really ever a problem with parking your car somewhere, right? Like there's parking lots, there's plenty of space. Like you drive up somewhere, you can find parking, it's free, it's no big deal. But if you drive into Nassau County or the city,
Queens, in that area,
all of a sudden you're now part of a bigger system that has to make do with the just sheer number of people that are also trying to park their car. And so you have to give up a little bit of your freedom in order to exist in this higher density population area.
Yeah, not all those people can just drive their car wherever they want to go.
Right.
That doesn't work.
And what happens when then that creeps into more of our lifestyles, like going and getting something to eat, where like you can't just show up at a restaurant. Now you have to eat from 7:15 to 7:45 because that's the only slot that we have for you. You know, it's an interesting juxtaposition on a country that founds itself on freedom, and yet we don't address at all the fact that the population is still growing and that there's just eventually not going to be enough space for everybody.
Yeah. I've seen some projections about like population growth in developing countries and things like that. And if I remember right, it's like US and China are predicted to level off in their population growth, but Africa and I think even India are actually projected to increase their population growth. And as those countries develop and basically enter industrial technology revolutions, there's going to be a massive problem with resources. So someone wrote a book about, it was a long time ago, but basically said that if every person on Earth lived like we do in the United States, we would need 4 Earths to sustain the resources. And that might be a reality if these countries, you know, continue with the population growth and the industry growth.
Yeah, it's something that we'll I'm sure, see being addressed within the political, going-ons. I think as we get a little bit older, I don't think it's something that world leaders are going to be able to avoid much longer. But we'll see.
Yeah, and also really interesting, I never thought how the demographic of a country would change based on how many people are born, whereas the number of people between like 16 and 25 would be way different from country to country, and that changes the whole scene, right? Like we were saying, where you're just coming into the professional field and stuff, and you have that many people, looking for jobs and innovating and doing things, that changes your whole country basically.
Right.
Yeah.
That's pretty crazy stuff to think about.
Yeah.
And then if your population decreases, you have that lump of people that eventually move to retirement all at the same time, and then you have an economic problem.
Yep. Which is where we're sort of headed.
Yeah,
Like,
Social Security wise, yeah.
we're like, we can't do this for everybody anymore. There's a lot of people.
Yeah. So just to finish up that last thought there, the book releases on October 30th, 2017, and can be pre-ordered on Amazon for $19.95 in paperback.
This one, actually.
Yeah, or $64.95 in hardcover.
That's a little much.
A little pricey, but
triple for the hardcover.
Yeah. But seems like a good read.
Yeah.
So if you guys were interested in that, go check that out. That's pretty much all the time we have for this week's episode.
Yep. So don't forget to tag us in any science news. Hopefully you enjoyed our wonderful guest, James.
Yeah.
I'm sure
I had a great time being here, guys. Thank you.
Yeah. Thank you for joining us, James. It was really awesome to have you on the show. We've been wanting to do something with you for a long time now, and I'm really happy that we were able to get Skype to work. So big shout out to Kyle for
helping us out.
Yeah, figuring that all out with us this evening. That's it for this week, guys. Stay tuned next week for more trèSci Weekly, and we will catch you then, Monday at 8:30.
Sounds good.
Signing off.
Bye, James. Bye, everybody.
See you guys.